Oops, hi class. Okay, this is our test 9 review. And I'm sorry, I'm going to be posting it just a few minutes late on Haiku, but if you're struggling a little bit with some of these problems, my suggestion is to watch this all the way through one time, take a break, do some other homework, and watch it again, and then take test 9, which should be proctored by a parent or an older sibling. If you do that, I think you're going to do pretty well on this. Pay attention, pay close attention to everything, every problem I work and everything I say here. All right, our first practice problem here we're going to work is a rate problem. These are very, very similar to the unit conversion, the unit multiplier problems we did with when we were converting, say, inches to feet and so forth. They'll give you something along the lines of what I have here, something like, it'll be a word problem that will say, Josh can skin 5 deer in 2 hours, okay? And then they'll ask, perhaps, how many deer can Josh skin in 12 hours, or how many hours will it take Josh to skin 30 deer? The first thing you'll need to do is to write your 2 rates. There'll always be 2 rates associated with a rate problem. Really simple. I'm going to abbreviate deer to D and hours to H in my rates. So Josh can skin 5 deer in 2 hours. And then the other rate, we're just going to write the inverse of that. Just flip it over. In 2 hours, Josh can skin 5 deer. Okay? That might be the hardest thing you do in these problems, is to make sure you get the rates written down. Next, you're going to solve the problem. They're going to ask you to answer in, well, at least for my problem, your answer in deer or in hours. So they might say how many deer in 12 hours, or they might say how many hours to skin a certain number of deer. Look at what they're asking. If they're asking you how many deer, you want to use the rate which has deer on top. If, as in number 2, they're asking how many hours, you're going to want to use the rate that has hours on top. We always want to use the rate or the unit multiplier that has a unit on top that we want to end with. So for question number 1, if I want to end with deer, I like to write that out in my answer. So it reminds me, they're asking how many deer. I need to have my answer in deer, okay? I need to have deer on top of my rate. So I'm going to write that rate here. 5 deer in 2 hours. Then we take the value they give me in the question. They're asking how many in 12 hours. So I write that here and I multiply it by my rate. 12 hours. Now we can see these hours are going to cancel, and I'm indeed going to be left with deer. And then, as I like to say, we just need to do the math. We take 12 and multiply it by 5 and divide by 2, our denominator here, 2. And that's 60 over 2, and that's 30. So Josh can skin 30 deer in 12 hours, right? Let's work the second problem real quick. Hopefully you don't need me to work the second problem because you have the idea of how this works. All right, second problem. How many hours to skin 30 deer? I want to know hours, so I need this rate here because it has hours on top. Come out here and write your answer, your units. It's a good reminder. All right, I need to use that rate. I'm going to write that down. I have to write down everything I know. How many hours? So what information did they give me? 30 deer. 30 deer times my rate. That's the hardest part, is just getting the right rate and then putting the right value to start. Now I just do the math. 30 times 2 is 60. And we divide that by 5. And that's 12. Okay? So it will take Josh 12 hours to skin 30 deer. And that's how we work rate problems. Okay? Next, let's see. I'm going to do an equal group problem. right? These are the type of problems that say they give you a number of something, and they want you to divide it into containers or buses or cars or classrooms, and they want to know how many cars or buses or classrooms you're going to need for all those items. Okay, in this case, we're going to say that you have $83, and you want to give away all of your money for Christmas to friends and relatives, but your mom says you can only give away $5 at most to each friend or family member. So you need to know, how many cards do I need to give $5 to give away all of my money, and give no more than $5 to each person, right? So I would take that amount and I would divide it by the number that I'm going to the number that I can give to each friend or family member. And my question is, how many cards am I going to need to give away all my money? Okay, my card is my container in this question. So 5 goes into 8 one time. 1 times 5 is 5. Bring down our 3. 5 goes into 33 6 times. 6 times 5 is 30. And I have a remainder of 3. So if I'm going to give $5 to each friend and family member, and I'm going to put those in cards, how many cards will I need to get rid of all $83? I'm going to need, in that same room with the Christmas clock again. I'm going to need 16 cards for $5 each, and then I'll have $3 left over, so I'll need a 17th card, and some unlucky person is going to get $3. So I will need 17 cards. And that's how I would work this equal group problem. Okay? Okay, next, let's look at range, mode, median, and mean. And many of you are probably thinking, oh, that's easy. It is easy. It's actually very easy. You just need to memorize what these definitions are. Okay, what are the definitions of each of these? Range, mode, median, mean. Mean's easy. That's just the average. Okay, mean is the average. So let me give you a list of numbers. My numbers are 19, 20, 32, 19, and 25. And I want to know the range, mode, median, and mean. Before you start, put your numbers in order from least to greatest. Do not just start picking out mode and median. Well, this is most important for the median, to be honest. So if I look at this list of numbers, 32 is not my median number. I first put them in order. Okay, and now 20, we can see, is my median value. So median is the number in the middle. Okay, 32 is not my median. Okay, I watched some of you work these problems and you were doing it without putting them in order from least to greatest. Range is very simple. All right, that's just the largest number minus the smallest number in your list. So our range of numbers goes from 19 to 32, that's 13. Mode is just the number that's repeated the most. That's 19. See how easy these are. And then the mean is the average. I'm not going to work that for you. All right? That's just add up all 5 numbers and divide by 5. That's how we calculate an average. I think most of you know that by now. But I do want to say something about the median number. In a list of numbers that's odd, so 3 numbers, 5 numbers, 7 numbers, it's real easy to find the median. Okay? It's the value in the middle. But when you have an even list of numbers, 6 numbers, 8 numbers, 10 numbers, I'm going to add an extra number here. Well, now you don't have a middle number, but what you have is you have 2 middle numbers, 19 and 20. Those are in the middle. Okay, there's 2 numbers before them and 2 numbers after them. So to find the median for this list, I would take 20 and 19 and add them up, and then I would find the average of those 2 numbers. So basically just add the 2 numbers, divide by 2. And that's 19 and a half. Okay, so for my list of 6 numbers, my median is actually 19.5. And my median for the 5 numbers was 20. That's important to remember. Right? And again, average If it were 5 numbers, I would add them up and divide by 5. If I had these 6 numbers, I would add them up and divide by 6. That's how you calculate the average. All right. The test is going to require that you understand prime numbers. I'm sure most of you do. A prime number is a number whose only factors are 1 and itself. So let's take the number 17. The only factors of 17 are 1 and 17. 17 can only be divided by 17 and 1 evenly. All right? And then the other concept you'll need to understand is multiples. I think most of you do. So, for example, that's like skip counting. If I skip count the number 3, 3, 6, 9, 12, 15, 18, those are the multiples of 3. So if I'm asked to list all the multiples of 2 between the numbers of 3 and 13, well, let's just start skip counting. 2, 4, 6, 8, 10, 12. Those would be all the multiples of 2 between the numbers 3 and 13. Pretty simple. Okay, you're going to need to add and subtract mixed numbers. Before I get into that, I want to reiterate that when we add and subtract fractions, we have to have a common denominator. So it's actually, to me anyway, it's actually easier to I just forgot how to spell denominator. Shame on me. It's actually easier to me I find it easier to multiply and divide fractions. So if you're adding or subtracting, you have to have a common denominator. And then once you have your common denominator, you add the numerators. Do not add the denominators, okay? 1/3 plus 1/3 is 2/3. It's not 2/6. Okay? Remember, when you add or subtract fractions, you add or subtract the numerators only. Okay? So let's move on to adding and subtracting mixed numbers. So let's say I have 5 1/3 plus 6 2/10 plus 4 1/2. All right, my first step here, I'm adding mixed numbers, which include fractions, so I have to find a common denominator for 3, 10, and 2. I'm going to use the multiple method. I'm going to start with my largest number. If I start with my largest number and just kind of slowly write its multiples, because I know I have to have a number that 10 goes into evenly. If I were to write out all the multiples of 2 or 3, I'd have a much longer list before I get to my least common multiple. So look at the number 10. 3 does not go into 10. Let's look at the number 20. Our denominator here, 3, does not go into 20. Let's look at the number 30. Does 3 go into 30? Yes. 10 goes into 30 evenly? Yes. And 2 also goes into 30 evenly. So our least common multiple, or our common denominator, is going to be 30 for this set of mixed numbers. So I like to say, write down everything you know. We know our whole numbers are going to remain the same. We know our denominator is 30. Write that down. I'm still adding. Okay, so look at our first mixed number, 5 1/3. What did I do to get from 3 to 30? I multiplied by 10, so I multiply my numerator by 10. Remember, whatever I do to the bottom of my fraction, I have to do to the top. What did I do to get from 10 to 30? I multiplied by multiplied by 3, so I do that to my numerator. Lastly, what did I do to get from 2 to 30? I multiplied by 15, so I do the same to my numerator. All right, our next step now, let's add our whole numbers, 5, 6, and 4. That's 15. Like I said, our denominator, when we add fractions, always stays the same. Now I just add my numerators, 10, 6, and 15, and that's 31. So my answer is 15 and 31 over 30. That fraction is improper. That's not the best way to leave it. If I want to simplify fully, I'm going to pull out a 30 over 30, which is 1. I'm going to pull a 30 out of 30 out of that, which is 1, and add it to my whole number. That gives me 16. What I'm really doing here is I'm taking 31 over 30 and I'm subtracting 30 over 30. And that gives me 1 over 30. Now I have this written in nice format with a whole number and a proper fraction. Okay? Let's go on to subtracting mixed numbers. All right, let's do 6 and 2/3 minus minus 3 and 3/4. Okay, I'm subtracting fractions here, mixed numbers, which include fractions. I need a common denominator. I'm going to do the multiple. I'm just going to list the multiple method. These are small numbers. I'm going to hit the right multiple pretty quickly here. It's 12. All right, so my common denominator is 12. Remember, the common denominator is the least common multiple. It's the multiple of 3 and 4, the smallest one that's common to both, and that's 12. So what did I do to get from 3 to 12? I multiplied it by 4, so I have to do that to my numerator, and that's 8. What did I do to get from 4 to 12 here? I multiplied it by 3, so I have to do that to my numerator, and that's 9. Okay, now I have common denominators, but my first fraction is, unfortunately, smaller than my second fraction. So now I have to borrow from my 6, right? I have to borrow. I need to borrow 1 so that my fraction, my first fraction, can be larger than my second fraction, and I can subtract. When I borrow 1 from my 6, I want to put it in fraction format that I can add to 8/12. So I'm going to call that 12 over 12, and I'm going to add it to 8 over 12. Okay, so I pulled a 12/12 out of my 6, and I'm adding it to my 8/12. Let's rewrite this. So I now have 5. I'm going to add 12 to 8, 20, and my denominator stays the same. Okay, minus my 3 and 9/12. Now I have this in a format I can simply subtract. I'm going to subtract my whole numbers, and that gives me 2. And I'm going to subtract my fractions, 20 over 12 minus 9 over 12, and that gives me 11 over 12. Did I do that right? Sometimes when I'm doing these problems, I make errors, and I don't catch them until I watch it a second time. Okay. That's how we subtract mixed numbers, right? First, find your common denominator. Second, if you need to borrow from your whole number in your first mixed number, do so by pulling out a fraction that uses this denominator. If that denominator were 8, I'd pull out 8 over 8. If that denominator were 7, I'd pull out 7 over 7, and so forth, and add it to that fraction. Okay? And then lastly, I'm just going to go ahead and subtract. I subtract my whole number, and I subtract my fraction portion. All right. Let's see. You are going to be asked to multiply fractions. All right. So let's say you have, you're going to be asked to multiply and divide. So let's say you have a string of fractions here. You're multiplying the first two, and you're dividing the last one. All right. When we multiply and divide, we just go left to right. All right. We can multiply our first two fractions, get the result of that, and then divide our last fraction. But let's rewrite this in let's take the next step here. When I divide fractions, I want to flip and multiply. So I'm going to flip my second fraction. So I'm going to put a multiplication symbol in there, and I'm going to flip that fraction and make that 12 over 10. And then the next thing I'm going to do is I don't want to multiply out all these numbers and then have to simplify. I'm going to cancel first by breaking these into some factors. All right, this is 6 times 3. This is 5 times 2. This is 4 times 2. And let's cancel as much as we can. Okay, this cancels with this 3. Oh, I got a 5 here that can cancel with that 5. This 2 cancels with that 2. Oh, I've got 2 6s. Cancel those. What do I have left? Let's see. Let's find what I have left. On top, I have a 3. And on the bottom, I have a 4 and a 2. All right. What is that then? 3 on top and 8 on the bottom. All right. And that's how we multiply and divide fractions. Where are we at? Let's see. Okay. You need to know how to change a mixed number into an improper fraction and an improper fraction into a mixed number. Actually, you only have to do one of them, but I'm not going to tell you which one. I want you to know both. All right. So let's say 5 and 2/7. All right, my top one is an improper fraction. It means the top is larger than the bottom. So to make this into a mixed number, which is 5 and 2/7 is a mixed number. It has a whole number and it has a fraction portion. I ask myself, how many times does my denominator go evenly into my numerator? 7 goes into 18 2 times evenly, and that's 14. And what's left over is 4, and my denominator stays the same. It's pretty simple. Down here, I have a mixed number, and I want to make that into an improper fraction. So what I do there is I multiply my whole number by my denominator. 5 times 7 is 35, and I add it to my numerator. So 5 times 7 is 35, plus 2 is 37. And my denominator, again, stays the same. Right? Make sure you know how to do improper to mixed and mixed to improper. Let's see. We're going to practice some order of operations here, where you have a long number sentence. It has different operations in it. It's got some addition, some subtraction, and some multiplication. Remember that when we have a long number sentence with various math operations, we want to do multiplication and division first, from left to right. Then we go back and we do our addition and subtraction from left to right. So I see here that I have multiplication here and multiplication here. So 7 times 3 is 21, and 4 times 2 is 8. I have to do those first. Now let's come back and copy the rest of our information back down again. Now I'm left with subtraction and addition, and I can just work those left to right. So 30 minus 21 is 9, plus 8, that's 17. Right? Remember, work your multiplication and division left to right, then work your addition and subtraction left to right. Okay. We're going to have to do some unit conversions also. They're going to want you to use 2 to kind of get from, I think if you recall, for example, if we were converting from inches to yards, and they'd stick, feet in there and want you to go inches to feet first and then to yards. So they want you to do a conversion using 2 unit multipliers. 2 unit multipliers. So in my example, I'm going to go from ounces to pints. These are liquid measures. Well, ounces, honestly, that can be a measure of weight as well, but I'm talking about liquid measure here. I want to go from ounces to pints, and I want to put cups in between. So I want you to go from ounces to cups to pints. Okay, so let me put all my unit multipliers down. This is sloppy, I'm going to rewrite it. So we want to go ounces to cups to pints. All right, so what would be my unit multipliers going from ounces to cups? Write down the largest measure and write 1 next to it. And then ask yourself, how many ounces go into 1 cup? And there's 8. Okay? And then you'll write the inverse of that. There's always two unit multipliers. And then we have to go also from cups to pints. Okay? So what is the larger measure? It's pint. I'm going to write 1 pint down and ask myself how many cups go into that. It's 2. And then I'm going to flip it. That's my second unit conversion. Now I have all my unit conversions here, all my unit multipliers. Now let's say that they asked me to convert 40 ounces to pints. So look in your problem and find out what it is they're converting, right? So that's the number you're going to start with. We're converting ounces to pints. I need to end in pints. But I have an interim measure here. I have to also go to cups to pints. So I need to go from cups, look at cups is on the top there, and then pints. I want to end in pints, but I have to stop at cups in between. So I want cups on the top there. All right? And I want to end in pints. Okay? So here I have, I'm going to just do my math now. I went from ounces, we're canceling ounces. We can see if we had just stopped with cups, I would end in cups here. See this unit here. But we're continuing on to pints. So now I need to cancel my cups. And what am I left with? You can see I'm left with pints, which is good. I want to end in pints. Now I know I have all my unit multipliers set up properly. Now, as I say, just do the math. Look at our numerators here. It's 40 and 1 and 1, or 40 times 1 times 1. That's just 40. And I'm going to divide that by my denominator, 8 and 2. 8 times 2 is 16. Okay, what does that come out to be? 40 divided by 16. 16 goes into 40 twice. That's 32. And I'm left with 8. All right. So I'm left with 8 over 16. And that's 2.5. 2.5 pints. All right. And that's how you would do a unit conversion using 2 unit multipliers. So going from 1 unit, ounces, to cups, and then to pints. All right. They want you to do decimal division. I've done a lot of those review problems. I'm not going to do another one here. Just make sure you know decimal division. Remember, you can never divide by a decimal number. Make sure you move your decimal all the way to the right in your divisor and move it the same amount in your dividend. Okay. What else have we here? Okay, they're going to give you a shape and want you to find the area. Okay. I did work one of these when I was teaching you about volume. Okay. This is a 3-step problem. When you are finding the area of a shape like this, you want to find the area of your square or rectangle there, and then the area of your triangle, and then you want to add them together. So remember that step 1, the area of a square or rectangle is side times side, and 2, the area of a triangle is 1/2 base times height, and then 3, you add them together. All right, so if this was 5 and 6, and say this long area at the bottom was, I don't know, 14, not to scale. My numbers are not to scale. So my area of my rectangle would be 5 times 6, that's 30. My area of my triangle here, the base would be, if this whole area is 14 and this is 5, then I know that this area is going to be 9. That's my base. And I know my height is 6 because of this. So that's 1/2. The base is 9 times the height, which is 6. And that's 9 times 6 is 54, and half of that is 27. So my last step is just to add up 30 plus 27, and that's 57 square units. If it were inches, it would be square inches. That's how you find the square area of this type of shape, which is like a square rectangle fused onto a triangle. Not hard, just takes 3 steps. What else here? Let's see. I think they're going to have you do a unit conversion with just 1. So beware, there's unit conversions using 2 unit multipliers, and there'll be a unit conversion also using just 1. Let's see. I think that's all. So if you want to watch this again, I suggest you take a break right now, go do some other homework, and come back and